Hello and welcome to Who's Who in the Zoo, and today we're going to talk about fire. It's a hot topic, and pardon the pun, but it is a very essential and critical part of every building we build, every space that we build. And to help us today, Rebecca has a guest on for us, Vance Rowe. Rebecca, tell us a bit about Vance.
Thank you, Rob, and thank you, Vance, for taking the time to be with us here on our Who's Who with the Zoo podcast. So, yes, Vance Rowe is a Queensland Manager for Price Holyoake here in Australia. He has quite an illustrious career from what I've seen in the bio he sent through to us. Prior to working in the HVAC industry, Vance worked as a plant engineer at an aluminum foundry working with furnaces, and he then commenced his career in the HVAC business in Holyoake Industries in New Zealand. More recently, he heads up the life safety products team at Price Holyoake, assisting designers, builders, and contractors with compliance for fire and smoke, and is actively involved in new product testing, training, and is part of a development team for these products. And he also works closely with organizations such as the AMCA, FPAA, and the NFPA to offer assistance and support specifically with fire and fire smoke dampers as an area of specialty for the company. So, as you might have gathered by now, he is a little bit of an expert in the area. So, Vance, why don't we start off with what drew you to the field? What is it that got you started in this whole thing?
The main interest for me really was, I fell into it, to be honest, Rebecca. Like most things in life, I don't think I understood fire dampers and smoke dampers when I was a very young engineer. Uh, when I joined the team at Holyoakes in around 1988, or late 1988, early 89, we had a lot of very, very good engineers that were very excited about air diffusion. Fire dampers were kind of the add-on. They were steel products, and nobody was really interested in them from that point of view. Being a young, impressionable engineer in those days, working for a very charismatic guy, Noel Holyoake, I saw it as an opportunity to take an interest in something that everybody else seemed to not be interested in. And as I grew into it and understood the interaction with fire and smoke, it became a lifelong fascination.
It was something that sparked it for you. Is it from that point that made you want to take an interest and get more into it? Pardon the pun.
Yes, there were a lot of conflicting theories about how they worked and how they were installed. I got a bit of experience overseas and learned about close control and in the pharmaceutical industry. And when I came to Australia, I had a good look around, and I was a bit concerned about some of the installation practice and some of the practices that were occurring at the time. And to be brutally honest, I was a little concerned about our approach to it as a business as well. So embarked on a testing and development program with the company to move us to where we are now.
Fabulous.
Um, Vance, is Price a firm that also sells fire dampers before they took on Holyoake, or is this a new thing for all of Canada, so to speak?
Uh,
That Price sells fire dampers.
So when Price took over Holyoake Industries, they were buying in third party fire products. That relationship ended, and they bought a company called Potteroff, actually, who that I'm due to visit. Actually, was due to visit this year, just couldn't make it, but we'll be visiting early next year. And they have a facility in Texas and some excellent products in that space. We are a little more advanced here in some of those areas, so we're sharing that technology as we move forward. The damper business in the States is a little different to what it is here in Australia, just with the UL 555 classifications. And a difference in opinion on insulation values with fire dampers. Australia seems to have taken the European route. I do apologise, thought I'd turn that off. Australia seems to have followed the European route, whereas the Americans haven't sort of followed the same protocols around insulation values.
Interesting, very interesting. So when you go to do like a fire risk assessment, what are the steps that you're going through? What are the things that you're considering? Vance?
Well, as I tell a lot of people, Rob, I know an awful lot about not very much, right? And that's probably the best way to describe it, right? So I tend to work quite closely with fire engineers and certifiers and mechanical engineers to get an understanding of what it is that they're looking for. I try and focus in my area of expertise, but often I'll be looking at other systems in the building. Many years ago, I used to test and certify stairwell extract systems and smoke exhaust systems and pressurization systems in New Zealand. So I have quite a background in overall building services in that space. Usually I'm looking at the outcome. Design's changed a lot over the last few years, and understanding the requirements of all the stakeholders is really important in order to work together as a team to provide a solution that works. Our piece of the solution is usually the last resort end, right? It will depend.
The last resort.
Yeah, it will depend on the fire engineer, but generally we are looking at a critical situation in a building where other systems have failed, and our products are the last products that are operational in that space.
The last line of defence. So, Vance, as I'm listening to you, I'm obviously working in this space, and I'm concerned that maybe some of our listeners may not have a grassroots understanding of what a damper is, what's a fire damper. So why don't we go back to kind of that basic understanding, so that when we talk about the last line of defence, we sort of really know what you're talking about there. What are the roles of fire dampers in our buildings?
Well, AS 1668.1 and 1682.1 define a fire damper as a device that prevents fire and products of combustion from passing through a fire barrier. We define a fire damper as the device that protects the airspace in the penetration. So whilst it's part of the fire barrier, it is really there to protect the airspace from that point of view. And it does seem to be a misunderstanding. I teach quite a lot right across Australia and more recently in New Zealand. And it does seem to be a misunderstanding around the term products of combustion. And products of combustion are smoke, are lint,
Yes.
sparks, gas, gaseous material, all of those things, really. And the fire damper's role is quite simply to prevent those products from passing from one side of the fire barrier to the other.
So, a little fusible link, which is a little bit like solder, melts and the curtain drops. Are you also selling intermittent dampers as well?
I have a hybrid mechanical intermittent damper. Actually, took several years to develop and quite a few more years to test through COVID. We don't sell at this point in time solely intermittent dampers. There are basically three types of dampers available on the market here in Australia. And they are curtain type dampers that work exactly as you said there, Rob. We have a solid link which melts at a specific temperature. Generally in Australia, you'll find that somewhere between 69 and 73 degrees, depending on the manufacturer. We're all around that space. And that's a what we call a curtain style damper, and they can be either vertically dropped and gravity fell, or horizontally installed with a spring closure and a locking mechanism. The second type of damper is what we call a motorized damper. That's a damper with axles on the blades, and more like a control damper type configuration. In the fire space, they still have a fusible link. They can be square or circular. The fusible link will melt, and generally the damper will close with a spring closure, which is usually attached to the damper. And the third type of, and again, those dampers will activate. Our one activates at 71 degrees. Um, the third type of damper in the market is an intumescent type damper or solar intumescent type damper. Intumescent materials react with heat, so they expand depending on the type of material, somewhere between 5 and 10 times their original thickness. And intumescent material, as a rule, will start to expand at about 180 degrees Celsius. So intumescent dampers are a very different type of damper from that point of view.
It needs to get a lot, by the sound of it, it needs to get a lot hotter.
Yes, and
And
and get and have consistent heat across it, Rob, as well. One of the reasons that we haven't delved into the intumescent market as yet, particularly with larger type intumescent dampers, because there is a consistent requirement of 180 degrees across the damper. I've found during demonstrations I've done here and testing that I've done here that we can get closure at the top of the damper and still have the bottom of the damper open at that point. And what happens at that point is that we can increase the velocity of the air through the damper. And the thing with fire is when we test a fire damper, we test it in a furnace, and we have to have an equal test, right? If you think about it from that point of view, because we need the same fire or the same level of heat to provide a consistent result across all types of dampers that are tested. So when we put a damper in the furnace, we've got the furnace ramps up using the standard fire temperature curve, and we've got an even temperature across the fire damper itself. When we actually have a fire, we have a different set of circumstances going on. We haven't got consistent heat around the fire, and we've got a lot of air moving into the fire as well. So that, particularly in a duct, when we've got a fire in a duct, we're actually drawing air into the fire at that point, and we can blast that air out through the damper. So I've seen dampers, for example, where I could put my hand on the bottom of an inch damper, but it's 400 degrees at the top. So when we look at intumescent materials are a fabulous fire prevention material. There's no doubt about that at all. The application of those materials and how they're applied to the space is incredibly important.
okay. All right. So when we talk, you mentioned earlier about getting in beside stakeholders. Let's break that down a bit. I think you said fire engineers, certifiers, and was it architects?
We don't tend to have a lot of discussion with architects about fire, which is disappointing from my point of view, because I'm certain that we could help them to make some better decisions in that space, particularly with some of the modern construction materials that we have and the different performance levels we have in that space. But generally, it's mechanical engineers. And what tends to happen is a lot of this falls on mechanical engineers. So a fire engineer will specify the fire compartment. Mechanical engineers will look at the penetrations going through the fire barrier, be they pipework, cabling, ductwork, that sort of thing. And this does tend to fall on the shoulders of the mechanical engineer.
So it's a nice segue for us, Vance. What are some of the big, let's call it common challenges that we're facing when we're talking about designing for fire in buildings?
Well, Rob, I've just spent a long time on the FPA Lithium Special Interest Group,
Okay.
and I presented at the FPA conference in New Zealand just a couple of months ago about emerging building risk, and I've done quite a lot of that in Australia as well. And without trying to scare the world, we've got some new risks that we've never had before. Um, I can say that since 2012, globally, fire deaths have actually been rising. Now, this is the first time in many many years that that's occurred, right? So we have population growth, obviously, that has contributed to that. But we're building buildings differently now. Buildings are airtight, and that's what we want in the HVAC world, right? It makes buildings energy efficient from that point of view. From a fire perspective, that's terrible. There's nowhere for the heat to go when we do have a fire. So we've gone from flashover of, say, 25, 30 minutes now to well less than 5 minutes with modern construction methods. We've got additional risks with lithium, and I do want to qualify this. There's a lot of scaremongering going on in around the world around the word lithium at the moment. Um, I've done quite a lot of work in this space, and recently conducted a webinar for the FPA with Emma Sutcliffe in that space. And that webinar was around what we call personal mobility vehicles. So if we have a look at our cities now, we've got a lot of people travelling via electric personal mobility vehicles, scooters, bicycles, hoverboards, skateboards, that sort of thing, uni wheels, all sorts of wonderful things are occurring in that space. And it does make sense. It's a very, very quick way of getting around a city, very green from that point of view. But the issues surrounding those products at the moment are immense. In New South Wales at the moment, they would attribute one fire a week at least to a personal mobility vehicle. And recently, talking to the Queensland Fire Service here, they're seeing similar sorts of figures. That issue is growing by about 60% year on year. And these things are going up quite quickly.
Just because we're buying more and more lithium-ion batteries. Jumping jumping back a step, when we talk about a lithium-ion fire,
Mm.
I imagine we're talking about runaway. The temperatures just get very hot very quickly.
Mm.
Are there any other issues? Is there an off-gassing
Yes.
thing?
So what happens at that point when we do go into thermal runaway? We have off gassing on the battery. The chemicals around that off gassing process are quite explosive. At that point, it doesn't take much to set them off. Once that process is started, the only way to stop it is to cool the cells down. Unfortunately, most large batteries are made up by multiple cells, and trying to get to the cell that is in thermal runaway is a quite a problem in that
Mm.
space. And typically, we could go from thermal runaway to fully fledged fire in the space of about 2 seconds, 2 to 3 seconds, right?
Wow.
So it's very very quick. Right. The issues that we're finding with those products at the moment, Rob, is that there are no regulation or no regulations in place in terms of what products are imported. So we don't know about the chemical makeup of the batteries. We don't understand too well or what's happening with the case protection on those sorts of devices. And there are issues around charging as well. Somebody damages a charger and pops out to JCar and buys something that is not compatible with the device, plugs it in, and it overheats. And in fact, Rob, I was at the Australian Fire Protection Association conference a while ago, and I plugged my phone into one of those mobile battery charging units.
Yeah.
And my phone had got a little wet in the wonderful Queensland weather, and while I was there, I could feel my phone getting hot. It expanded. The glass on the front of the phone started to lift away from the case. That afternoon, I got it in for repair, and my local guy said I was pretty lucky, basically, at that point.
Mm,
So,
mm,
it can happen to all of us in that space. I understand globally uh, that we would be expecting somewhere around 40 odd lithium ion powered devices in every household within the next 5 years.
wow.
So the growth in that space is quite high. Um,
Yeah.
One of the videos that I show my students actually is of these vaping units. The rechargeable lithium powered vaping units. There's been a lot of those going off in people's pockets, and the hospitals are full of people that are burnt by those sorts of devices. So, on the one hand, we've got a group of products that's quite different to what we've had to deal with in the past. I would say to you that in Australia and New Zealand, we've been quite complacent because we haven't had large building fires with a lot of fire deaths. Tragically, we had a fire death in northern New South Wales due to an electric bike just a little while ago. Strangely, bikes seem to be about the worst device, according to the New South Wales Fire Service at the moment.
Mm. Everyone's expecting that to be cars, but you're saying it's
Oh,
bikes.
cars are cars are quite different, actually, Rob. The cars have quite concise battery management systems in them. So from that point of view, the technology is really, really good, and it's able to shut down charging in most cases before a problem occurs. Right?
Mm.
If you have a look at EV car fires around you, you tend to find that there's some other factor that's occurred uh, um,
Okay.
during that space. But personal mobility vehicles, on the other hand, just don't have that sort of technology in the charging. So on one hand, we've got those products that we haven't had before. We've got more synthetic materials, more cellulose types of products, synthetic products now in furniture that we haven't had in the past. So whilst they take a little longer to catch fire, they burn with more intensity, and they run to flash over much faster than what they have. We're building with new materials. I mean, for years and years, we've put fire dampers into walls and floors that don't burn. Now we're putting fire dampers into CLT, for example, which does burn, right? And when we have fire, it goes looking for oxygen. So we start to see different things occurring with those sorts of devices than what we have in the past.
So on that point, CLT or compact laminated timber, they are arguing that they char and therefore they don't form ignition.
That's correct. Yeah.
Um, so in those cases, is it a better thing than concrete? Where are the differences between concrete and CLT as far as fire barriers are concerned?
Well, typically concrete doesn't burn. I mean, it does change, obviously. It changes state and it will deflect like every other product in a fire situation. But we don't have to worry about fire within the fire barrier itself, right, in that space. Um,
Oh,
so the difference with CLT is that we actually get fire on the product. So we talk about char. Now, char is a very polite way of saying that we're reducing the mass of the material. And in actual fact, fire itself obviously is molecules moving together very, very quickly, creating gas. And obviously it's the gas that burns, right, within that space. So in testing fire products in CLT, when we test them, the wall's on fire, right? When we test a fire damper in a concrete wall or a plasterboard wall, the wall's not on fire at that point, right? So we don't have fire looking for oxygen quite the same as we would with a concrete wall, for example, than what we do with a CLT wall floor in that space. And that means that we get performance that is quite different because obviously, fire with concrete is when we test it is provided by the furnace. The last fire test that I looked at was CLT. They turned the furnace off.
Wow. So with CLT, you said that there's obviously these gases potentially still moving together. Would that cause like I imagine sometimes with concrete and high temperatures, little bits of it explode away.
Yes.
With CLT, is it coming apart because it's compact and laminated?
Didn't see it coming apart. I certainly have no evidence of it coming apart as such, Rob. And like I say, it does char. And common theory is that it's structurally stable until it gets to 50% of its original thickness, depending on what it is.
Right.
But with CLT, we talk about CLT as if it's one thing. It's not, and that's one of the issues that we've got in the construction space at the moment. With different manufacturers, obviously, they're using different laminates, different glues. The laminates are running in different directions. If we don't understand what the makeup is of the bonding agent within the CLT, we really don't understand how it's going to perform. Now, the CLT manufacturers obviously test their materials, but we can't state that CLT is a product that's the same. CLT is a product group, but there's many different types of CLT within that space.
Okay. All right. So just to recap, we started this question with what are some common and modern challenges we
right.
face?
So, yeah.
You said tight buildings.
Yeah.
You said that there is a greater prevalence of these products that could potentially catch fire. And then you said we've got a whole lot more synthetic stuff to burn inside our buildings. And then finally, I think you've said that we may be getting less aware of the products that we're using when we go and build our buildings, or they're less knowledgeable. Like for us, we know what concrete looks like, and then we've got CLT with potentially different bonding agents in it. Have I missed anything? Is there anything more there, Vance? It's very interesting about.
Well, obviously, there's lots of practical challenges that I see in that space as well. So we'll find that there'll be different products put together in the same penetration. And each of those products in their own right may be fire tested, right? But when you put them together, the junction is really important, and the way that they're deflecting is really, really important from that point of view. So they may not operate in a penetration the way that they did in their original fire test. And that's a common issue that I have with builders and architects and in that space, particularly when they put forward evidence of those products. And I'll say, well, actually, has anybody ever cut a hole in it, right? and have we actually tested it and looked at the joint and the deflection of that product when it's installed in a piece of concrete or in a speed panel or co-rock wall in that space, and looked at what's happening with deflection, and are we putting the seal at risk between the damper and the wall in that space. So there's lots of issues around that at the moment. And there's lots of issues in understanding how these products deflect in that space. I.e., a floor with wooden floor joists in it is quite different to a floor with rolled steel beams, for example, or lightweight type steel roll form construction, right?
So it's a good segue then into how do we balance, or what do you propose we say to balance costs and aesthetics and all the other, let's say, non-fire pressures with the fire design?
Well, generally, quite often we can get those products to work. I do quite a lot of testing in those sorts of situations where we have to put hybrid wall or floor systems together, and often there's really good reasons for that, right? For example, if we're building a secure facility and it needs steel work through lightweight construction walls, and we've got plywood and plasterboard and and other components within the wall system, right? So often what we can do is we can look at that componentry, and we can look at its performance. We can put that in front of a test lab. We can build that up, put it in a wall, test it, see how it goes. Have a look at then what happens with the junction between all of those components in the fire damper, right? I guess the key to understanding this is we can have an FRL for a component, but we need an FRL for the entire assembly. Now, often somebody will come to me, for example, and say, look, we've got this wall, and the product's got an FRL. And then I'll say, but what about all of these other products that are within the wall construction as well? Well, they've got one as well. Well, have they got one together? Right? Oh, no. But doesn't it all add up? Right? And it doesn't, because things deflect in different ways in that space.
Okay. All right. So I think I don't want to say that you're dodging the question, but I might just say you're dodging the question here, there, Vance. The question is, what do you
What can I do?
what do you propose to people
Mm.
when they want to talk about saving money,
Mm.
or they want to talk about a particular aesthetic outcome, and you've got this kind of technical, principled outlook of things that you need to achieve? What do you say, or what are your tactics for addressing that tension?
Well,
Is it perhaps just to come back to standards and codes? This is the law. This is the building code law. Or
no. Recently done this. Usually, what I'll do is have a look at the outcome that's required, and then propose a solution. Now, often that's a compromise. Often that might be a piece of plasterboard where somebody doesn't want to see it, or we might have to put a wider flange on the damper, those sorts of things. But generally, we will work with people to find a solution that's as close to what it is that they were looking for as possible, right?
is the Price Holyoake testing facility, is that a useful tool in deriving these combinations and testing these combinations before they get built?
We've got a small furnace, actually in our Auckland operation, so lucky enough to get across there to play with that from time to time, and hopefully we will have a furnace in our Queensland operation very shortly. So I'll be able to do more of that here in my backyard, as it were.
Mm.
It is extremely useful in understanding how things work on a micro scale before we go to a testing authority. We don't NADA certify our own testing and development facility, Rob, because I don't believe that that's the correct thing to do for a manufacturer. I think everything should be independently tested, and I work with a number of testing authorities, but most of our testing is done by these days by the CSIRO, certainly in the fire space, and they, in the nicest possible way, because I do get on with those people very well, they are the hardest people to deal with and the most critical people to deal with, right? And I have found that with brands as well, and you want to test your products in that environment, right? Particularly in Queensland, I'm sure you're aware of the Non-Conforming Products Chain of Responsibility and Other Matters Act. That actually makes me, as a senior person here, responsible for every single product that comes out of our factory. So I don't take that sort of thing lightly. I want to know that whatever it is that we're putting out in the marketplace is not putting my family at risk. Yeah, in case I'm personally sued. Something that occurs in that space, right? Aside from obviously my interest in ensuring that we've got safe buildings.
So, Vance, we've heard a lot of challenges, and they are eye-opening. What's on the other side of the ledger? What new innovations or technologies or tactics do you see emerging that seem to be helping combat some of these challenges?
Well, I've seen some incredible innovation over the last few years. If we were talking about suppression technology, for example. There's encapsulation type technology now for fire suppression, which changes fire on a molecular level, which is very, very exciting. That's quite new. And that's in its infancy here in Australia right now. Companies like us, for example, we've spent a lot of time reducing leakage in dampers. We're at leakage rates now of 18% of the required leakage amount in the testing code in spaces that we've never been able to get to before in that space. I think hybrid technology, using the benefits of intumescent technology and the benefits of steel and other type composite products, really, really good. I also think protection awareness is really, really important. I'm a little controversial, I guess, in my point of view, Rob, where I believe that insulating walls and fire dampers sometimes can be detrimental from a fire risk point of view. And I guess what I mean by that is that if we wrap a damper and protect the external surfaces and ensure that we're retaining that heat within the damper. And if we were to follow AS 1668.1, for example, we have a 2-metre piece of duct attached to that damper that doesn't have to be insulated to maintain the insulation value of the wall, right? Now, if we were to shorten that duct up, which we're allowed to do under 1668.1, and we wrap the damper, and let's say we had that duct at 400 millimetres away from the fire damper, often we've got a piece of flexible ducting connected to that. Could be within 400 mil of a fire damper that might be at 1,000 degrees, and we've moved that heat risk from the fire damper now to something that actually is combustible. Right. So I think it's time to start thinking a little differently to fire separation, and start to look at how we can safely radiate that heat away from the device that's causing us a problem. If we were to look at how fire service personnel fight fires, for example, they ventilate fires, right? And they do that for a number of reasons. They need to move the heat out of the space, obviously, to lessen the risk of flashover. Sometimes they're looking to try and burn all of the fuel in that space as quickly as they can to ensure that that fire doesn't move throughout the building. And if we were to apply some of that logic to wall penetrations, for example, and floor penetrations, we might start to see a safer outcome by radiating that heat back out into the space and ensuring that nothing that's combustible can come into contact with that. And
you've touched on a couple of points that, in my opinion, are well worth going over. I've never understood why, if you've got a damper, why adding duct and then insulating it somehow improve the performance of the damper. The insulating component, particularly if it's going to take 180 degrees to show up versus 75, strikes me as a potentially less safe option. And then running this duct on either side of the walls, it just doesn't feel like it makes things safer. Because all that heat, as you're describing it, if it's in that damper, then it's going to melt or distort or twist or turn or crack or whatever it's going to do. It just doesn't seem to make sense. I recall when they changed some of the thinking around framing of aluminium windows, and we were going to put thermal breaks everywhere and insulate everything. And of course, it was perhaps immature in its approach, but then we had glass breakages from buildings and glass popping out of buildings. This idea that we've tested something in the lab and then somehow gone and built 2,000 square meters of facade with it and not appreciated the physics of it is, I think, a really great threat or danger to how we are building. So anyway, listen, I had some other tough questions here for you, Vance. bushfires. At the moment, we are doing a number of bushfire assessments and
Mm.
how do these rooms stay coolish during bushfire periods. And we're doing the opposite of what you and I were just discussing around dampers. We're trying to make things reflect heat,
Mm.
cool down quickly, not have too much thermal mass, and those sorts of tactics. What have you seen? I mean, because climate change does appear to be driving at least the frequency, if not the intensity, the drying out of these, bushes and this woodland. What do you see as some responses that can be brought to bear with bushfires?
Hmm. Uh, well,
For example, does Price Holyoake, sorry to cut you off, does Price Holyoake get into barrel ratings and putting barrel screens
we
on louvers?
we do get involved with that on our on louvers, and we'll put them on the front and the rear of louvers to meet the bell ratings in that space. It's a really interesting concept, that one, isn't it? We'll put a bell screen on the front of a louver, but I'm not aware of the maintenance that needs to occur after that, right? So whenever we put something that's got a limitation on it, we're going to get a buildup of debris inside that screen. Uh,
Fire load, you're going to get a build up of fire load on that
uh,
screen.
that's right. And if we don't understand that we need to keep that clean on a regular basis, we actually could be increasing the risk, right?
I mean, I don't
In
want to
space.
create fear mongering, but I certainly watch and review drawings where people are putting these barrel screens, which they're like insect screens for those who are not sort of concerned about it. It's to minimise the entry of embers into a building. But if it also is a place where we're storing fire load, an ember hits that, that's going to be where our fire actually commences.
Absolutely. Yeah,
Mm,
absolutely.
mm.
Look, I think I think the encapsulation technology is really, really exciting in that space. I'm seeing some early results in that space that I think would have a significant effect on buildings in bushfire zones that are combustible. I'm certainly not an expert in that space, by the way, Robert. Like I said, I know an awful lot of things about a very small subject, right?
Could you tell, for my benefit as well as for our listeners, what encapsulation technology is? I'm imagining it is things like an intumescent additive or an intumescent, uh, paint that's being added to a product to kind of slow down fire growth. What are you talking about with encapsulation technology?
It comes out of the states, and like I said, I'm not an expert in that area. I know a few of them, and in fact, saw a demonstration not too long ago in that space. But as I understand it, it encapsulates the molecular structure, right, of what's actually happening within the fire, and shuts it down and very, very
Okay,
quickly. It reduces the temperature, right, of the fire molecules very, very quickly.
right. Okay.
Yeah,
So it's needs to be found at the seat of the fire, and then whatever chemical it's releasing
from
takes a lot of energy and quickly reduces the
that's
temperature
right.
of the
Yeah, yeah.
right.
The one that I've seen, Rob's mixed with water, sprayed on fire, and it doesn't smother a fire like we do with traditional type systems. It goes after the molecules within the fire itself.
Mm.
Mm.
Well, that's pretty cool. So, Vance, one last thing, in terms of your experiences in what deals with fire. Um, have there been some standouts in terms of safety measures, design measures, installation measures? What are the two things that you think are, really important from providing safe egress in fires and safe management of the fire situation itself? What are two measures that really stand out?
Well, that's an interesting one. To limit that to only two is pretty tricky, right?
I was thinking about what are the go-tos that, as long as we've got those, we're going to be pretty right. Like a really
Yeah.
simple one for me would probably be sprinklers, right? That's
Look, sprinklers save lives. There's no doubt about it. The research, I've been having a discussion with a lot of people about this in relation to actuators, for example, Rob, uh, and in particular actuators that are on dampers that are in smoke exhaust systems, right? I saw some research a couple of years ago that the CSIRO had done with fire and rescue in New South Wales, where they'd looked at temperatures within a sprinkler fire and temperatures within a non-sprinklered fire, and literally the highest temperature the ceiling got to in a sprinklered fire was 95 degrees, right, in that space. So I would advocate the use of sprinklers everywhere. I think that they save lives. They're obviously not too good for property from that point of view, and I understand there's cost associated with them and that sort of thing as well. But I think we need to get serious about it. I'm an advocate of sprinklers and everything you can see. I'm actually an advocate of external sprinklers on domestic dwellings that are built in bushfire zones as well, Rob. Right. If you protect your space correctly, it's unlikely that you're going to provide the conditions for fire to continue. Right. So definitely sprinklers. Secondly, I would say education and honesty about what we're doing in our space, and understanding that the measures that we put into buildings, particularly the passive measures, right, are quite different, right, to everything else we're doing in the building from that point of view. A fire damper looks the same as a piece of ductwork, right? But if you don't connect a piece of ductwork correctly, you get a little bit of noise and a bit of leakage, and it costs you more energy, which obviously we don't want. I'm not an advocate for doing that, right? But if we don't mount the fire damper correctly onto the wall, right, or the floor, somebody could die. Right? It's as simple as that. So making sure that we follow the instructions that are in front of us, right? Making sure that the wall and floor substrates that we're putting these devices into have actually been tested, and that goes to pipe collars and all of those sorts of devices, cable protection, right? Making sure that we're actually following the rules in that space. Sealants is another one. Sealants are often widely misused in the construction industry. They've got temperature limitations. I've seen sealant catch fire. If we put chemically cured sealant into a space where we can't vent those gases out, those VOCs, and we put heat onto those gases through the outside of the outside skin of a constructed wall, those gases can catch fire inside and explode and start to burn the wall from the inside out. I've seen that sort of stuff in testing that we've done. We need to be careful about what I say here in case my employers are listening, but we often have a beer and set fire to something on a Friday afternoon just to see how it's going to perform and what it's going to do, and a lot of that so-called fun that we're having on a Friday afternoon has ended up in the removal of items of products that we've produced, and the addition of design and a lot of movement forward within the business, right? So you're paying attention to installation is critically important, I think.
Yep. Yeah. So every damper that's drawn and purchased, following the installer's test certificate, getting it checked and reviewed, getting all of that in place, the right separation distances from other
Yeah.
penetrations. That's what you're talking about.
Yeah, absolutely. Yeah. There's a reason that you can't put services, within 200 millimeters of each other, right? There's a lot of heat coming off those uninsulated items, and that could be pipework as much as there is a fire damper in that space. Right?
Mm. Vance, let's return a bit more back to your role. And I know broadly your role is a manager's role. And you mentioned before we started on the show that you're into a new role. What could you just go back over what that new role is?
So it's to develop our life safety products business. There's a lot of space for us to add additional product support in terms of what it is that we do. There are a lot of from that point of view, there's some new products I want to bring on board. There's some products that we've got here that we'll redevelop that are specific for certain situations, right? We tended to have taken a one-size-fits-all approach. I think with building design changing the way that it has, I've been involved in buildings, for example, where we want to put air on a fire-affected floor, right? Because we have to move smoke away from the egress zone, right, in that space. So we have to have a look at how those products are likely to perform in a fire environment. We assume that we've got a sprinkler controlled building, so we're not going to get high temperature in that space. But what happens if that doesn't work? I've seen buildings that have been signed off, been populated, and the primary sprinkler pump won't work, right, in that space. So we all know that this sort of thing occurs. I mean, hopefully less frequently than what it has in the past. But as a manufacturer, we want to develop products that have got more than 2 or 3 safety features on them. Our dampers, for example, I'm not here to sell our dampers, by the way, Rob, but our dampers, we build the sleeve that goes around the damper with quite a light gauge material. And I remember when I first came to Australia, people saying to me, "Well, that's not very good. That's not very heavy." Well, in actual fact, the reason we've done that is that if somebody puts the wrong fixing right through that material, it's thin enough to tear without ripping the fire damper out of the wall, right? Now, it took me nearly 10 years to have that conversation with the industry, right, and get people to actually listen to that sort of thing. So, it's that sort of innovation that we want to keep doing. We want to make sure that we can alleviate the things that can go wrong when people make mistakes on site. So firstly, that development aspect of it is going to be quite enormous. I do a lot of advocacy, so I sit on the FPAA Technical Advisory Committee 18 and 19 for passive fire, and I chair the newly created Mechanical Committee there, and sit on the National Technical Advisory Committee as well. So, and that takes a lot of time. I mean, just this week I've probably spent a day and a half in meetings. Represent the FPA on ME62, which looks after 1668 and 1682. And it takes hours and hours and hours of my time to sort of go through those things and actually understand the meaning of what's written in front of us, have a look at what's actually happening out there and see if we can improve on what we're doing, try and get a feel for construction issues and move that forward. So a lot of time in advocacy. I do that also in New Zealand. So recently met with the Chief Fire Engineer in New Zealand at the fire conference and had a discussion with them about standards and the building code in New Zealand. Really want to keep doing that, and obviously part of this role will be doing that. I actually teach validation and have just finished writing a course in partnership with the AMCA on fire damper and smoke damper installation. We'll be teaching the pilot course for that next year. So this allows me time away to put back to industry. I'm a bit of an old head, Rob, and I think we've all got a responsibility to pass on the knowledge that we've got. If you ask me about challenges in industry, I think that's one of them, right? So I like to spend at least 20% of my time giving back to industry in that space. And thankfully, I work for a group of people that are quite well prepared to support that. Um, and lastly, quality assurance, I think, is a really important factor in manufacturing fire and smoke products. And I think we could all do better in that space. I come from a manufacturing background, obviously, and when you say managerial role, you'll often see me in a pair of overalls underneath a roll former out in the factory, Rob. Uh, Thankfully, I still have those old skills and are able to play around with that sort of machinery. But just tightening up those practices, making sure that we understand each component in the process, we can verify those components and the operation of those components and those devices going forward, and pretty much being able to provide something that I would be happy to put my family in, right? And that's the way that I look at it. So I'm a very lucky individual from that point of view, being given the opportunity to do that within our business.
But is it possible, a bit like you're like the fire engineer that knew too much? Are there any sort of things that keep you awake at night?
Lots,
Just about work, Vance, just about work.
lots of things that keep me awake at night. Yeah. I think, look, I have I have this joke with my students and the people around the AMCA and FBA know this quite well. If anybody's booking accommodation for me, it's on the second floor, right? I don't like to be above the second floor. Um, I think that we've still got too many buildings that don't work, Rob, in our building stock here in Australia and in New Zealand, for that matter. So I think that there's quite high risk in some of these buildings, particularly with us not understanding the volume of lithium devices that are going into those spaces, for example.
Yeah. That statistic you said is frightening.
Yeah,
40 potential fire sources that all need to be charged, so they're all often
yeah,
going into that risk situation.
yeah,
That's quite a statistic.
yeah. Well, look, I bought a polisher for my boat the other day, Rob, and it's 40. It's a 40 volt, um, you know, 6 amp hour battery on that polisher. Now, the amount of stored energy in that thing is phenomenal. And I'll own that battery, I can tell you now, for 2 years before it's safely disposed of. Because we do get crystal growth in those batteries as well, and that actually smashes the separation across them. So I'm very careful with those sorts of devices. So that keeps me up at night. That very much keeps me up at night. The understanding that we are at the bottom end of the curve, and what I think is the lithium risk, right, going forward. Um, and that's extended now to solar battery panels on houses, right? For example, in
Hmm.
domestic housing, there's quite a few of those gone up across Australia. We had all of those bikes go up in the hotel in Adelaide just a little while ago. So that really is concerning me at the moment. Look, I get concerned when I go down to my local office works, and I see the phone battery disposal bin right in the only entrance door there is to the shop.
To get out. Yeah.
Right?
Wow, such a simple thing, but with education, you would make a change in that
Yeah,
position.
yeah.
Yeah.
So that keeps me up at night. I guess um, the one of the other things I guess that keeps me up at night is um, how do we keep going? How do we continue to pass this knowledge on to the rest of the people in our industry, right? Where's the facility for doing that? I think universities and schools are doing a great job in terms of training, but when I chaired the Chamber of Commerce in Harlow in the UK, I remember sitting down with the university professors around there who explained to me that technology was changing so fast that students that started a course often the technology had changed during their degree, right, and was different to what it was
Yeah.
when they started, right? Um,
So you're right. I think there needs to be a kind of a first principles understanding of what's going on.
yeah,
and then we can come along and interpret what's the code trying to do.
Yeah.
But there's more than 2,000 changes in code on average per year. So that's the code and the associated Australian standards. How any engineer can say, look, I'm across it all, is a real challenge. So, Vance, we have enjoyed a whole hour, one of our longest podcasts. It has been quite riveting, and the time has gone very, very quickly. I hope that you and your family and your work colleagues have a terrific Christmas. Thanks for coming on to Who's Who in the Zoo.
Thank you very much, Rob. Thoroughly enjoyed it.
It was good fun, wasn't it? All right. Take care, Vance.
Right.
See you soon.
Bye.
Bye.